Hello students, welcome back to Physics with Safdar. Now you are watching IGCSE Physics Past Paper Solution series. In this series we solve question from paper 2, 4 and 6. So today we are going to solve questions from paper 4 and this is Specimen 2020 series. So let's start the solutions of the day. Question number 1 is 1.1 figure shows the speed time graph of a car traveling along a straight road. The graph shows how the speed of the car changes as the car passes through a small town. You can see in this graph, vertical axis, the quantity is the speed with unit meter per second. Horizontal axis, you have time in seconds. In this graph, we have different sections. So let's start with the first one. This horizontal line shows the car is moving with the steady speed. Then A to B, decelerate, enters the town, then move with the constant speed till point C, leaves the town, then point D, it's the acceleration portion, once again a steady speed. Now look at this question. Calculate the distance between the start of the town and the end of the town. It is very clear in the graph, point B enters to here and point C leaves town here. Now, if you have a speed time graph, then how to calculate the distance covered by the object? For that you need to recall this basic information. Area under the line is equal to distance covered. Look at this graph. This is the required line B to C, and what we need to calculate area under this line. How to do that? In step 1, you draw a line from point B on time axis, then C to time axis, and you need to draw this line. So finally what we get a rectangle. So area under the line, basically we are getting a rectangle. To calculate the area you need to know the dimensions of a rectangle. So let's start with this one. First of all, this side is 13 meter per second. So you can measure from 0 till this point. It gives you 13 meter per second. On horizontal axis you can see this is the starting point. You can read from 0 till this 18 second, and this point is 42 second. If you want to know the distance travel in this interval, you subtract 18 with 42 and you get 24 second. Now area under the line basically is equal to area of rectangle. Now you know the sides 24 and 30, so multiply this number and finally you get area under the line is 312 meter, and that's the final answer or distance covered from B to C. Now this is part B of question number 1. Calculate the acceleration of the car between C and D. Jump on the graph. You can see this is the point C and point D. So this is the line we have, and we need to calculate the acceleration in this section. Remember one thing, if you have a speed time graph and you want to calculate the acceleration is equals to gradient of the line. Here we have the line CD, so we need to calculate its gradient. First of all, you need to make some construction here. So look at this. First you draw a line from point D and then a line from point C. Then you get a triangle. To calculate the gradient of the line, you need to know two lengths, this vertical height and this horizontal. This is 12 in value. You can read this measurement by using this scale easily. In this scale, if you start reading 0, then it is line number 1, 2, 3, and similarly you will get 10. Here is line 1, shows numerical value 1. So when you read from here, you get it is 42. Then this number you can read from here, it is 54. When you subtract 42 with 54, then you get 12. On vertical, it is 18 in number. In the same way, you can measure this number from this scale easily. So you have vertical and horizontal value, and gradient simple is equals to vertical axis value divided by horizontal axis value. So gradient of line C D 18 over 12, it gives 1.5, and that is the acceleration required, 1.5 meter per second square. Second method, it's up to you. You can use any one of these. Second method, we are using by the definition of simple acceleration. Acceleration is equals to change in velocity over time. That means v minus u. Here v is the final velocity, u is initial, and t is the time interval. Jump on the graph, then you see this line from C on speed axis. You can read 13 meter per second. That's the start. So you will write it as 13 meter per second initial velocity. Point D, at the end of this journey, you can read final velocity here according to the scale, 31 meter per second, and the time interval is same, 12 seconds. When you substitute the number, the final velocity is 31, initial is 13, time interval is 12. Subtract the numbers, then you get 18 over 12. 18 over 12 gives you 1.5 meter per second square. This is the required acceleration. So both methods give the same answer. It's up to you. You can choose according to your convenience. This is part C of question 1. State how the graph shows the deceleration of the car has the same numerical value as its acceleration. One more time, jump on the graph so you can see this portion CD is showing acceleration, and the section AB showing deceleration, and you need to answer these two sections have the same numerical value. From the part B, you know well the acceleration was 1.5 meter per second squared, and you have to prove here the deceleration has the same number. Remember one thing, if you want to acceleration or deceleration from a speed time graph, then you need to calculate the gradient, or by using the rate of change of velocity formula. Look at this, what we do. First you draw a line from point A, then B, you get a triangle like this. You can read the numbers easily. From point A, this is the 25, and it is showing initial velocity. This section is showing the final velocity, which is 13 meter per second. If you calculate the change in velocity, that is final minus initial, that means 13 minus 25. It gives you minus 12. And horizontal axis you have time. This section is 8 seconds, so you can read from this scale easily. Look at this acceleration definition again, that is the change in velocity over time. V is final, U is initial, and T is time interval. Now you can substitute all the numbers. V is 13, U is 25, time is 8. And finally you get acceleration minus 1.5 meter per second square. Because here we have the negative sign, that means it is deceleration. Now it is very simple. In the part B, the acceleration was plus 1.5 meter per second square, and here you calculated deceleration minus with the same number 1.5 meter per second square. So in this question you can write you are getting the same numerical value. What's the reason behind it? Because in both cases they have the same gradient or slope. That is your final answer. Thank you very much for watching this video. I suggest you follow the playlist of the channel. In that you can find all the lessons you need in your IGCSE physics. So keep watching Physics with Safdar for better results in exam. See you in the next lesson.